YouTube landers, we're going to do a comparison between the properties of ionic compounds, simple covalent molecules of compounds, and metals. All right, let's get right to it. Yeah, ionic compounds are usually crystalline solids at room temperature. All right, and that is because of the giant lattice structure that it has. There are tons and tons and tons and tons of ionic bonds, which means a lot of energy to break those bonds up. So they are solid at room temperature. They are also visible because there are billions and billions and billions and billions and billions and billions and billions of ions in a single grain of ionic compound, like salt. Simple covalent compounds are usually liquids or gases at room temperature, and that's because they are simple molecules that has covalent bonds, right? But between different molecules, you got molecule A, and then you got the molecule, and between the molecules, you have weak intermolecular forces, all right? Weak intermolecular forces. Metals now are often solids at room temperature, and that's again because of the many and many billions and billions and billions and billions and billions and billions of metallic bonds between the giant lattice structure. However, there are exceptions like mercury, liquid at room temperature, and gallium, which is a piece of metal that upon touching it, it will turn to liquid. Wow, amazing. All right, ionic bonds, compounds have high melting and boiling points, and that's because of that lattice structure that I talked about a while ago. Covalent molecules, on the other hand, have low melting points, and that's because it's held together by weak intermolecular forces. Metals, again, have usually a high melting and boiling points, and again, is due to the lattice structure. All right? Okay, now, ionic compounds often are soluble in water, and that's because it has a positive and negative charge, and water itself has a region of partial positivity and a region of partial negativity. Well, that's beyond our curriculum, but water's properties allows it to pull those ions apart. The attraction between the water molecules and those ions can sometimes be strong enough whereby it pulls those ions apart. I mean, it breaks off those ionic bonds. Okay? Simple covalent compounds are usually soluble only in organic solvents, and a few are soluble in water. All right? And it's the concept of like attracting like. So, yeah. And metals are insoluble in water, but some of it, the more reactive metals, tend to react with water. Whoa, to form alkaline solution. Anyway, ionic compounds, they will only conduct electricity in the molten state or in aqueous solutions, and that's because of the free moving ions. All right, free moving ions. Simple covalent compounds does not conduct electricity at all because there are no free moving ions and no free moving electrons. Metals, on the other hand, can conduct electricity either in the solid state or in the liquid state or molten state, and that's because it has free moving electrons no matter in what state it has. Okay, and so this electrical conductivity is only a comparison between the solid state and the liquid state. All right.